All right, so we're in part 3 of the visual display of data, multiple choice questions. Common theme, once again, we were looking at this on box plots. Here we have percentages. Instead of having a box plot, this is just a segmented bar graph. Black is activity A, this is activity B, and that color is activity C. Once again, they do not tell us how many students are in each group. So if we don't know how many 6th graders are, there could be 40 6th graders, 300 7th graders, and 10 8th graders. We don't know because they didn't tell us. So if they're asking us to compare numbers, how many 6th graders that were in activity A compared to how many 7th graders were in activity A, we can't say how many there are because we don't know how many people, students were there. So in this, we can only compare numbers for within a group. I can say the number of students in activity A for 7th grade is less than the number of students in activity B for 7th grade. But I don't know I can't say that the number of students in activity A for 6th grade is less than the number of students in activity A for 7th grade, because I don't know how many students. If there's 200 students here and 4 students here, then it doesn't matter what the percentages are. So the idea is, just like in the box plot questions, you can compare percentages between the grades, grades 6, 7, and 8. We can see who has the largest percent. But when it starts asking you to compare numbers between the two, grade 7 and grade 8 had the same number of students. How do I know that? I don't know how many students they got. So just make sure, usually for these questions, you're either comparing numbers within the grade or you're comparing percentages between the grades, just like we did in the box and whisker plots. This one, we did that one, did this one. We'll get there. All right, so here we obviously have a histogram. It looks like that it's skewed to the right. Notice in all these, we're looking at either histograms, we're looking at stem and leaf plots, but we're just looking at the same things. It's skewed to the right. What do I know about that, right? It's talking about the median and the mean, and it's also looking at outliers. It gives you quarter 1, quarter 3. So we have a way to figure out what outliers are. Remember, to find an outlier, we do quarter 3 plus 1.5 times the IQR. Anything bigger than that is an outlier. And quarter 1 minus 1.5 times the IQR. Now, since my quarter 1 is 2, and my IQR is 3, and I don't go past 0, I'm not going to have an outlier to the left. Since this looks like it's skewed to the right, and I'm getting some data points down there, I'm probably going to have some outliers over here to the right. And then we got to know where the median is versus the mean. We talked about that with the skewness. What happens to the mean as it gets skewed to the right? Go back and look that up if you forget. I have a paper in the drive that discusses this. It's in the visual display of data. It's called Mean and Median and Skewed Data. Look it up again. For here, this was on the 2017. They really didn't ask something like this before, but this one goes back towards the beginning of the year when we're looking at categorical data. And we have to understand that since I have categories, this kind of looks like our independence test, the chi-square test. We have categorical data. The only thing we can use for categorical data are pie charts or segment and bar charts. So scatter plot would be if we had quantitative. We just were plotting numbers. Box plot, we need numbers. Back-to-back stem plot, we need numbers. Dot plot, we need quantitative numbers that were matching up to each other. Segmented bar chart would be for the categories. So that's the only one that we could do for this. I know we didn't do it in a while, so. The other thing you can look at is these 4 are for quantitative data. This one isn't, so that's probably the answer. But those are freebie for you guys. All right, so over here, we talked about in histograms, if you forget how to get the range, go back and look at the histogram video. Remember, we're looking at intervals because we don't know where the numbers are. How to get the median. Again, we don't have exact values for medians when we're doing a histogram. We have An interval, a range. So remember that. Do not say it's directly that. Figure out exactly. You can tell me what the max range is or what the min range is. Tell me what the max median is, what the min median is. Tell me there's a range for the quartiles, but you cannot give me exact numbers for this. So make sure you look at that and look back at the video. This one. Once again, it's just asking you about the 5-number summary. The range we want to look at, interquartile range is simple. It's just, here's quarter 3, here's quarter 1. We're just, what's the distance from here to here? Make sure you know what your scales are. Number of days. Do we know how many days? Number of on-time arrivals for a sample of 100 flights. So we do know how many days we have 100 flights. That at least 80 on-time arrivals is greater than the number of days that had 76. So if we can look, number of on-time arrivals, can we figure that out? So can we figure out number of days from here? And then the difference between the median and lower quartile is less than 2. Can we figure that out? So just think about what this tells us and if we can actually use it. Here we're looking at dot plots. We want to find the first quartile, the median, the third quartile, the range, and the interquartile range. What I would do for each of these is I would number. There's 28 of them. So if you remember how to do the median, think about where the median would be, what position. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just number them. Oh, 11, 12, 13, 14, 15, and so forth. Figure out where the median would be. Once you get the median, figure out where the quartiles would be. And just write them out. See which one, what you have for each of them. What's quarter 1 for corn? Corn quarter 1, soybean quarter 1. You can see what they are. Just by counting out the dot plots. Ooh, beautiful technology. That's not even really. Here we go with the box plots. You see this again. First thing that I notice, remember what these mean. The medians are the same.